Hello, today we're going to work on geometric sequence and series. In this case, you are looking to check if the pattern has a common ratio. We are going to focus on three rather specific rules. The first one to find an nth term, the second one to find the geometric mean, and the third one to find the sum of a specific number of terms when you have a geometric sequence. Let's start. Find the ninth term of the geometric sequence given. In order to do so, you want to start by finding the common ratio. In this case, it is 10 over -5 or divided by -5, giving you a -2. And if that's the case, let's go ahead and find the ninth term. To find the ninth term, I will simply replace my a sub n with a sub 9, and continuing on, I am looking for the ninth term, but I do know that the first term is -5, which I need to multiply by the common ratio, -2 raised to a power of 8. Making sure to simplify this part first if you are doing this manually. So a sub 9, where I need to multiply -5 right here by -2 to the 8th, or simply a positive 256. And in this case, the ninth term is actually -1280. Continuing on, we are going to find the 10th term of a geometric sequence with only the given information, the 5th term and the 7th term. Similarly, you want to start by finding the common ratio. I have already started to add the information we need. We are going to use the 7th term and the 5th term to find our ratio. In this case, our exponent n-1 will become a 7 minus 5 because we are using the 7th and the 5th term. So my 7th term is 384. My 5th term is a 96, and I am left with r squared. Let's go ahead and simplify the given expression to find your common ratio. In doing so, we are able to find that 384 divided by 96 is a 4. However, take note, this is an r squared. We must simplify it to simply find the common ratio. If we do so, and you find the square root, your common ratio will result in two values, a +2 and a -2, which means to tell us that there are two cases, and it does happen. So in this case, let's go ahead and go forward to find the missing piece, which is to find the 10th term of the given geometric sequence. In order to do so, we do need to find the first term. We want to start with a common ratio of -2. Note how I divided the table so that on the left side I am working to find the first term when the common ratio is -2, and on the right side when the common ratio is a +2. Let's start. I am looking for a sub 1, and once again you are free to use whether the 5th or the 7th term. In this case, I'll use the 5th term. Our 5th term is 96, and I am looking for the first term with a common ratio -2, which will now be raised to 5 minus 1. Let's simplify some more. I have a 96. I am looking for the first term, but this means I need to raise -2 to the 4th power. And -2 to the 4th power will give you a +16. And in this case, I can see that the first term is actually 6. And to check, well, will it have the same value as when your common ratio is a +2? Let's see. Essentially, I'll have a 96 using the 5th term once again. I am looking for the first term, but this time my common ratio is a 2, and my exponent will still be 5 minus 1. Continuing on, a 96, I am looking for the first term, and this time I do need to raise 2 to the 4th power, and that will give me a positive 16. It so happens that the first term, when a common ratio of positive 2 is given, is also a positive 6. Now we are going to go forward and find the 10th term. Alright, here we go. So let's start once again with the left column. Common ratio is a negative 2. Alright, I'll use a sub 10, and using the first term where r will be raised to a 10 minus 1. So let's go on ahead. A sub 10, we are looking for this 10th term, our first term being a 6, multiplied by our common ratio negative 2 to the 9th power. And so our 10th term will have 6 multiplied by negative 2 to the 9th, which will give you a value of negative 512. And in doing so, we find that the 10th term is actually negative 3072 when our common ratio is a negative 2. On the other hand, let's find the 10th term when our common ratio is a positive 2. Alright, similarly, 10th term, our first term being a 6, and this time a common ratio of positive 2 to the 9th power. Continuing on, I'll have a 6, and 2 to the 9th is a positive 512, and our 10th term in this case is a positive 3072. You do have a second option to find the common ratio, then replace a sub n and a sub 1 for any other given information. Note that you must also apply the change to n minus 1 in r to the n minus 1, or when you're looking for the common ratio. You do need the common ratio to begin. So similar to how you found the arithmetic sequence, we are also able to manipulate the given general rule. So let's go ahead and try that out. So now that we do know the common ratio, a negative 2 and a positive 2, let's start with a ratio of negative 2. And I do have my 5th term being 96, and our common ratio of negative 2 to the 5th power. And negative 2 to the 5th power is going to give us our value, which is also a negative number, negative 32. And when you do multiply this, you would get a negative 3072. Similarly, if I apply the same values, looking for the 10th term, where my 5th term is a 96, this time I am looking for a common ratio of positive 2 to the 5th power. You will have a 96 multiplied by 32, giving you your positive 3072. Very much like what you obtained in the previous slide, where we found the first term before finding the 10th term. And now we proceed to work on the geometric mean. To find the geometric mean, you multiply the two values and find their square root. In this case, I'll work with 16 and 25. In doing so, I found the product to be 400. But we do know the square root of 400 is 20. And that's how you find the geometric mean. Alright, let's go forward. At this point, we've been able to use our general rule to find the nth term. And so now we are going to work on finding the sum of specific terms in a geometric sequence using the following rule. Let's begin. In this case, we are instructed to find the sum of the first 7 terms with a given pattern. I've taken note that we have the first term to be a positive 3, a common ratio of negative 2 where you have negative 6 divided by 3, where it is also equal to 12 divided by negative 6. And of course our end value, which is a 7. Let's go ahead and continue, where the first term is a 3. And now I need to input the following values. My common ratio to be a negative 2, the power n, which is to the 7th, all over 1 minus the common ratio of negative 2. Now you have the option to type this into your calculator or do it manually. In this case, I'll continue by showing you first how to manually simplify. First, go ahead and simplify negative 2 to the 7th, which will give me a negative 128 all over 1 plus 2. I'll continue simplifying. I'll have a 3 multiplied by 1 plus 128 all over 3. And from here you are seeing that you can simplify 3 and 3 out, so your sum for the first 7 terms in the given pattern is actually 129. At the end of the video, I will attach a short clip to show you how to type this into your calculator instead of doing it manually step by step. But now you do have the background to be able to perform the operations without the use of technology.